All right, so here's our next problem. This time we're trying to find the concentration of a base solution. All right, so I'm first going to sketch out my titration curve. All right, pH is going to go on the y, and this time I'm going to be adding acid into this base. So this is going to be volume of HCl, and this is again going to be in milliliters. Okay. Now this time I'm starting in a base solution, so my pH is going to be high initially, and then it's going to go down to low. Here's my equivalence point. Okay, so that's my equivalence point. And this is still a hydroxide base with a strong acid, so my pH is still going to be around 7. And my equivalence point is going to fall at 27.4 milliliters. Okay. All right, so I'm trying to find moles of barium hydroxide per liter solution. Okay, I know that I have 20 milliliters of this barium hydroxide solution, so I already got the bottom. So I just need to get the top. That's what I'm trying to find. All right, so my first step is going to be to write the equation. Now this one's a little different than the last one I did because this hydroxide, this metal hydroxide actually has 2 moles of hydroxide ion for every 1 mole of barium ion, which means that when I make my balanced equation, I'm going to make barium chloride plus water, okay? And this time I'm going to end up making 2 moles of water and using 2 moles of HCl. So when I do that's going to affect the moles of barium hydroxide that I have. And I'm again going to start with my volume of acid and not the molarity of acid, because what I'm trying to find is not in itself a conversion factor. It's a single unit. So I'm going to start with a single unit. 27.4 milliliters HCl times 1 liter over 10 to the third milliliters. Okay, get my milliliters into liters so that I can use the molarity to find the moles. Okay, and then I can convert the moles of HCl, which this time there are 2 moles HCl for every 1 mole barium hydroxide. Okay, my answer here is 2.110 times 10 to the minus 4 moles barium hydroxide. Okay. And I can put this up here. Barium hydroxide for every, or in 20.0 milliliters of solution. Okay. And that's, oh, I'm not equaling yet. Okay, I still need to convert from milliliters to liters. Okay, and that will give me 1.05 times 10 to the minus 2 molar barium hydroxide. And this one has 3 sig figs because this number has 3 sig figs, this number has 3 sig figs, and this number has 3 sig figs. Okay, so this is titration problems. These are pretty straightforward, and you should enjoy some success here.